This is the second part of a tutorial where you are designing and building this keyboard. In this video, we are going to finish our schematic and import everything into PCB. If you haven't watched the previous part, the link is in the description. Now, let's start. We are going to add switches into our schematic, but we not only need switches, but also this socket. When we have a look on the other side of the PCB, this is the socket where we can plug in the switch, and it's super useful because then you can use any kind of switches what you prefer. Okay, this is how you plug it in. So we need the socket and we also need the button or the switch. I'm going to close this and we are going to search for mechanical keyboard shaft. And let's have a look. This is a switch. This is white color socket. This is the black one. I'm going to copy the LCSC part number and we are going to use it in our schematic. So go on the other page and find the socket, place it. Now, this is not exactly what we would like to have because the socket itself is not really switch. So go to project, project libraries, find the socket what we just placed into our schematic, and I'm going to save it as my own symbol, RF version 1 symbol, and we are going to make some adjustments. Yes, we would like to create also footprint. Okay, go to personal libraries. Here it is. Edit device. And let's make some changes. So I'm going to delete this, okay? It's not a button. It's only a socket. And I'm going to make it look similar as the socket looks. So place these lines. Watch the grid, okay? It will help you to draw the socket exactly same way as how I'm drawing this. Okay, and just place this arc and also the second one. So this looks, this symbol then looks very similar to the real socket, and now everyone knows what this symbol will represent. Don't forget, okay, use 0.1 grid, save it. There is no 3D model, so I'm going to find this Kyle 3D model. You can see that it's not there, we need it. So I'm going to search for 3D model of this socket. And okay, register and login, it's free. I'm going to download it. This is the file what we downloaded, and inside of the file there is this 3D model step file. I'm going to copy it into our project directory. I'm going to rename it. And okay, this is the directory where I have it. I'm going to copy it, and we need to upload it here into our project. So first go to File, New 3D Model. Here, go to the project directory. This is the 3D model what we downloaded. Open. This will upload the 3D model to the libraries, so then we can use them. And now add the 3D model. It is in our personal libraries. Here is the 3D model. and now we have it in our PCB. Okay, so this is the footprint, and we are going to make small changes. I'm going to move this 0, 0 position because we would like to make it easy when we will be placing these sockets on the top of our switch. Find this PDF. It's the switch PDF, and here this is something very useful. This will tell you where we need to place the socket and where is the middle of the switch. We would like to have 0, 0 position of this socket. Where is the 0, 0 position of the switch, because then it will be easy when we are doing placement. Okay, so this grid is 50 mils. And you can very easily calculate where we need to move the 0, 0 position. Use mils, and first I'm going to move it into middle of this hole. So canvas origin, move it to the position of the hole. This is the position of the hole, so watch what is going to happen. Okay, and then from this position we can move it based on the data sheet. Okay, so we are here and we need to move it here. It is 50 mils, so this is 150 and this is 100. Okay, again, move the origin by coordinate, and here 150, 100. Watch what's going to happen. Perfect. Okay, now it will be super easy to place the socket. This is correct. Oh, this is not correct. It's a little bit off. So I'm going to correct it, okay? I'm going to move it to 100. And it looks like we also need to move something that is on different layer. Here it is. No, not this one. This one. Yeah, but we also need to move this. Okay. Perfect. Cool. Okay, so this is the footprint is something what we will use when we will be doing PCB layout. It has to be correct. Okay, this is the symbol, and now we are going to add 3D model, so don't forget to add 3D model. Go again to personal, select it. We need to add the 3D model now again because we corrected the footprint. So I'm going to place the 3D model exactly as it should be placed. So it's upside down. And be sure the pins are placed correctly on the pins of the footprint. This looks good. This looks okay. And perfect. Now it's finished. We can save it. And when we double check the 3D model, here it is. Go to our schematic. We don't need this. We can delete it. And we are going to place our symbol. And place it, for example, somewhere here. Okay, so this is this socket. And there is something else what we need. Do you know what we need? We also need the switch. So again, search for the mechanical keyboard shaft because it also shows some of the switches. We can use this one. We don't really need to care about this. I only would like to use the footprint and symbol, so double check the Easy EDA model if they have something. Okay, I'm going to copy this. So we are going to use this only as a starting point, and we will change the symbol and footprint by ourselves. so we don't have to draw it from scratch. Place the switch inside of our schematic. We are going to edit the symbol. So in project libraries, find it. Now save as. I'm going to add RF version 1, and we are going to save it into our personal libraries. Okay, create new footprint. Go to personal libraries. Don't forget to refresh. Here it is. And let's make changes. So right click, edit device. Now this time we are not going to have the pins because pins are in the socket. So I'm going to delete the pins and change the grid and make the symbol a little bit nicer. I'm going to redraw it so it looks like a push button. We are creating this symbol. We would like to add this symbol into our schematic for two reasons. First one is we would like to have it in BOM, bill of material, and the second reason is we would like to have 3D model of this switch in our PCB. Okay, so even if there are no pins, we still would like to add this symbol into our schematic because it is useful. Okay, this looks good. You can save it. Don't forget to change the grid back again. And we also would like to adjust the footprint. So edit footprint. And we deleted the pins, okay? So we need to remove the pins from the footprint. Be sure you are in mils. Grid size 50, because that's what is in the datasheet of the switch. It will be easier for us to work with the footprint. I'm going to move the origin to the middle of the switch button. So based on the position of the hole, we can move the origin. And I'm just checking the position. Okay, this is the position. But we don't need them, okay? So what I'm going to do, I'm just going to draw on the top seal screen layer. So this is the layer which is usually the white color on PCB. This is only to show where we would like to have holes for the socket. I'm going to double check what is the size of the holes so I can use the same size. It's 59.1. So I'm going to change this. 59.1, and also for this one. Okay, and now when we know where the holes should be, we can delete these pins. And also these, I don't know what is this. Oops. Okay, delete again. Okay, perfect. And delete also this. Okay, so there will be the holes. We may add few more holes because there are more variants of the switches. So there is also a switch with extra legs. So we are going to place extra holes into this footprint. It's for the biggest compatibility for as many switches as possible. So this is the size. We need to put here size of the holes, and this is the position. Okay, so I'm going to put here 200. This is one hole. I'm going to copy it and place it also on the other side and double check the position 200. Okay, and some of the switches, they have also LEDs, and in our case we would like to use LED, but SMD LED, but we would like to place it directly into the right position. So I'm going to mark where our SMD LED should be. I'm going to mark it on the top seal screen layer, be sure it is selected. Am I simply going to just draw this cross? Okay, so when we will be placing our SMD LEDs, the middle of the LED, we would like to have it in the middle of the cross. Okay, okay, perfect. This will make the placement easier. Save it. And we can add a 3D model or double check 3D model. I'm double checking this 3D model and it doesn't have these legs at the bottom. Maybe we would like to find different 3D model because you know, we would like to double check the position of the holes. So I'm going to have a look if there is 3D model of a switch with the legs at the bottom. Let's have a look. Oh, this one has the pins and also the legs. So I'm going to download it. This is the file what we downloaded. This is the 3D model. I'm going to rename it. I'm going to add the RF version 1 and copy the path, or remember the path where the 3D model is located. We are going to upload the 3D model into our personal libraries. And now we can find it. So in the personal libraries, we are going to use the 3D model what we have downloaded. Here it is. We need to adjust the position, so I'm going to change this. And double check, okay, there are the pins and there are the legs. We just need to move it a little bit. Put here these numbers. Okay, and you can see pins, they go directly into middle of the holes, and these are the legs, they are going inside, and there is the position for the LED. Okay, I'm going to move it down, and perfect. I'm just double checking everything. See, position of the holes is correct. Where the pins are located, there will be the socket, so don't worry that there are no paths or something. So there will be holes from the socket. The holes are in the socket. Okay, we can place it into our schematic. Just double check 3D model. And I'm going to delete this, select it, place, and this is the switch. Perfect. I'm going to close everything. And save. Now, double check how we need to connect this. It's called matrix keyboard schematic. So these switches, they are connected into matrix, and we will also need this diode. So we not only need the socket and the switch, but we also need a diode. I'm going to find something. Schottky diode will be fine. And we just need a small one, so we can use this SOD 323. And almost any diode is fine. There is no picture. This one looks good. Okay, let's have a look. I'm going to copy LCST part number, and we can use it in our schematic. Place it, and place it somewhere here, okay? Be sure you place it in the correct direction. It has to face like this. I'm going to make it a little bit nicer. Okay, and this is going to be like the one block of components needed for one switch. In the QMK firmware, we need to double check how this matrix is connected. Here you can find how the matrix is connected in this QMK software, and here they also write about the diode, so if you like you can read here to find out more information why we need it. But basically the switches, they are connected into columns and rows. That's what we are going to do. Okay, I'm going to connect this first, copy this block, and paste it 9 times, because we would like to use 9 switches, so we are going to place it 9 times. If you need more switches, then place as many switches as you need. Okay, so you don't need to have 9 switches on your keyboard, you can put there more. Okay, save. And now we are going to draw the connections for the columns and for the rows. Do it like this. And I will draw the connection this way a little bit longer, because a little bit later we would like to add few more switches which are connected in the encoders. You will see later, okay? But for now I will connect these 9 switches which are here. So I'm going to copy this and place it also here and also here. These are the columns, and we also need the rows. So I'm going to draw it from here to here, also down here and here. Okay, this we will use a little bit later. Okay, save everything. We would like to connect these. We would like to connect it to the microcontroller. Here are the columns and here are the rows. So I'm going to place this net port. We are going to use net port because these nets, they go on the different page. That's why we are not using the standard labels. We are using these ports. And call them column 0, 1, and 2. I'm going to rename this. And to make it faster, you can actually use automatic numbering. So here I'm going to show you how you can make it faster. I'm going to place this output port, because these are outputs actually, and press Tab on your keyboard. You can change the name, and now it will automatically increment the number. Okay, so the columns are input to this page and the rows are output. Notice, see, these are the inputs. And on our microcontroller schematic page, we need to place also ports, but this time we will use output. So it is output on this microcontroller schematic page, and it is input on the other page where are the switches. And it's output because the signal will go out, okay, from the microcontroller. Okay, and for the rows, we are going to use inputs. They are outputs on the other page, and they are inputs on the microcontroller page. Press spacebar to rotate and place them here. Okay. Now we need to connect them. Where do we need to connect them? How do we find out? So let's search for QMK define matrix pins and adding your keyboard to QMK. Can we connect them to any pins? So here is the information in info.json matrix configuration. Okay, this is how you specify the pins. So it looks like we can actually connect the columns and rows to any pin. I'm going to find this info.json file specifically for RP2040 microcontroller, just to double check if they use the pins of the, or how they name the pins of the microcontroller. For example, here we can find it, and pins, and oh, basically you just say GPX. Here is an example. Okay, so for RP2040 you just say for example GP0, GP1, and that's how you specify where the rows and columns are connected. So we can connect them to any pins, and basically we can connect these column pins to these pins, and rows we will connect to these other pins. But I'm not going to connect these columns directly. I'm going to use this 27 ohm resistor. And the reason is it can help to improve signal. Some of the keyboards may be very large and the signals or the tracks can be very long. So sometimes maybe you may need to play with the values of these resistors. Even if you use 0 ohm resistor, it's fine, but 27 is a little bit better because it can help to improve the quality of the signal. I'm going to name these because they are important nets, so I'm going to just name them like column 0R, column 1R, column 2R. This is called series termination, these 27 ohm resistors. If you would like to learn more about series termination, you can find out in some of my videos, or just have a look on my YouTube channel. And we would like to add this simple low-pass filter. It's just a resistor and capacitor, but we are not going to use it. We will use like a 0 ohm resistor initially. And you can use this filter only if you need it. Again, if you have a very large keyboard, maybe the signal may be very noisy, so then you can fit this filter. But on our very small keyboard, we are not going to use it. I just would like to include it in the schematic. It's good to have it there in case you have problems. You can play with this filter. So we are going to find 0 ohm resistor. Okay, we can use this one. So basically in our schematic it will be like connected directly to the pin, and we will not fit the capacitor. I'm going to place it into our schematic, and I'm going to create the filters here. Okay, make it nicer. And 100 nanofarad capacitor. That's the second component for filter. But as I said, we will not fit it. I will just place it here and then mark as not fitted. Connect the second pin of the capacitor to ground. Resistor is connected to the other page in our schematic. Connect everything together, and this side of the filter will be connected to the microcontroller. So I'm going to name the net, and I'm going to call it like row 0_R. Okay. Save it. I'm going to put a name here. And I'm going to mark it as optional, so everyone knows we are not going to use this by default. Use 0 ohm resistors and do not fit the 100 nanofarad capacitor. Okay, so this is the 0 and this is the capacitor, and do not fit it. Place the not fitted text on the top of the capacitor, and that's it. Copy the whole block, and we have 3 rows, so we need 3 filters. Copy and paste, copy and paste, and connect it correctly. So I'm going to delete this and move this here, delete this and move this one here, and also don't forget to change this. Row 1, and this one is going to be row 2. Perfect. I'm going to make a note. So everyone knows when this filter can be used. So initially we don't fit it and only use it if you need it, okay? And if you need it, replace the resistor and fit the capacitor based on the values which you will calculate. Or you can use some default values and you will see how it will help. I'm going to make it a little bit smaller. Perfect. Save it. Now we are going to connect everything to microcontroller. So everything what we need to do, we just need to place the net names here. I'm going to copy it and paste it on this GPIO 8, GPIO 9, and GPIO 10. Here and here, if you like, if you have more keys, you can put there more columns and more rows. I'm going to put some text here. I already tested this connection on my bigger keyboard, so it works. Okay, so in case you have more switches and you need more columns and more rows, just use these additional pins here. This one would be column 3, this one would be column 4. I'm going to move it. Okay, the next one you can use as column 5. I connected, I think, like 50 switches, and it worked perfectly fine. And here are the additional rows, in case you need them. So I'm going to make a note. This one would be row 3. And actually we will use this row 3 a little bit later. You will see when we will be connecting the switches from the encoders. So you will actually see how to use this additional row connection. Okay. So all these switches are now connected to our microcontroller. these are not connected right now, so I'm going to mark them. And don't forget to save everything. Next are the encoders. Okay, so here you can rotate the encoder and you can also press the encoder. So that's the switch. And we are going to find what kind of encoder we could use. So rotary encoders. I will just find something what they have in stock, something like this, something what is not very expensive, but there are many options what kind of encoders you can use in your schematic. If you like, you can buy more of them because there are differences. And I don't like this symbol, so we are going to adjust it. So in the libraries, project libraries, find the symbol what we just, or find the component what we just placed into our schematic, save it into our personal library, and we will make the symbol nicer so everyone knows immediately that it's an encoder and how it is connected. We would like to create also new footprint, and in personal libraries, refresh. We would like to edit the device. I'm going to close this, and we are going to make this symbol nicer. So we would like to work with pins. I'm going to make them a little bit longer, and be sure the grid is 0.1 inch. This is the middle, and I'm going to place pins like this. We need a little bit more space, so I'm moving these pins. Don't forget, when you work with filter, don't forget to enable again everything. Okay, and I'm going to have a look how these pins are connected. So pin 1 and 2 are connected to the switch. And then also, this is interesting, we may need some filter to place around this encoder. This is the one what we are using, okay. So let's find it here. It's not this one, almost. Okay, it's this one, 4 and S, okay. Here are the pins, and it means these 1 and 2 are connected to the button. So I'm going to draw a small button. I will use smaller grid. And you can draw it, for example, like this. It's always useful to have nice symbols, so everyone immediately understands how the pins are connected, what is inside of the component. Okay, this way everyone will know that these pins are connected to the button. And we also need to connect the other pins. But first I will draw this in the middle. This is just the kind of visual interpretation of the encoder. And now the pins down here, they are connected like this. This is one contact. This is the other contact, and this is connected here. Now this. And it's much nicer. Don't forget to change the grid back. And we would like to edit also footprint, or double check the footprint, just to be sure it is correct, because this is moved a little bit. I think, notice, see, it's moved. It's not in 0, 0 position. I don't know why they created the footprint this way, but we are going to move this origin. It will make it easier when we will be placing this component into our PCB, especially when we will be doing the enclosure. Double check if it's in the middle, okay? The middle of the circle needs to be in 0, 0 position. Okay, this looks good. Because if there is offset, you know, and when we will be doing enclosure, then maybe we would drill the hole in wrong position. Double check the 3D model. It looks good. Actually, it looks very nice. I like it. Okay, so we can just close this and we can use it. I'm going to delete this old symbol. And we can use our new symbol. So place it into our schematic. We can close this. And let's continue. So close this. Now press spacebar to rotate. Pin 1 is down, so I'm going to flip it. Okay. Looks nice. How to connect this? Do you know? In datasheet there was the filter circuit, this one. We need to add we need to add these 10K resistors around the encoder, and also these capacitors. We already have 10K resistor in our schematic, so I'm going to copy it and just paste it. We need one here, and we need also two more. One here and one here. I can connect it. Oops. Move it a little bit up. And connect it also here. These are connected where? You can double check. Power. In our case, it's 3.3 volt. So I'm going to copy 3.3 volt and place it here. We are using 3.3 volts because, do you know why? Because these signals will be connected to microcontroller, and microcontroller is powered by 3.3 volts. So we really don't want to use 5 volts here. And we also need these 10 nanofarad capacitors. We need to place them here. So we are going to find them. Just put here 10 nanofarad. Okay. Go to capacitors, Samsung 0402 10 nanofarad in stock, and order based on stock, and we can use this. Copy. double check where it is connected, and find it, and place it. We need one here, another one here, draw the connection, and connect them to ground. So I'm going to copy the ground symbol, and place it here. By the way, of course, you can use Ctrl+C, Ctrl+V on your keyboard. You don't need to press right click and do copy and paste. But I do it this way because I don't want to use shortcuts in tutorials. Now I'm going to place one more capacitor, which is not in the data sheet, but I would like to have a little bit bigger capacitor close to this encoder just to be sure the power is stable and there is no noise, like this. Okay, we can connect also this switch. We are going to connect it to this matrix. So I'm going to draw it like this. We need the diode, and we need to add one row. Row 3, connect it, and basically here I'm going to put the net names. So this one is column 0, it's column 0, confirm, and this second one I'm just going to call it like, I don't know, encoder 1 switch. Okay, and these two we need to connect them to the encoder. So I'm going to copy and paste them here, draw the line, and place the net names on the top of the line. This we need to connect to ground. So that's the shield. And one more here. Okay. Save everything. Now we need to connect this row to our microcontroller. I'm going to copy this filter circuit also for the row 3, just in case we need it. Don't forget to rename it. I'm going to copy the name and paste it. I like to copy and paste the names because then, you know, I'm sure I will not make mistakes by writing them by hand. And we can delete this node. We can delete this marking, and we can connect the third row here. Perfect. Okay. Save. Now, where to connect this? I'm going to search again QMK encoder, and let's have a look how they recommend to connect this. So here they specify the pins where the encoder is connected, and again it looks like very simple. We can just specify there any pins, so we can connect the encoder to the next pins, GPIO 15 and 16, and again I'm going to use ports, input ports, and I'm just going to connect these to the microcontroller, and the other side, the output ports on the other page, we will connect to the encoder. Okay, so go here, place the output pins here, and connect them to microcontroller. So it means use exactly the same name. Paste it here and use the second name. Just copy it and paste it. Okay, this looks good. I'm going to name the encoder. Because then we would like to copy the whole block. So I'm going to put everything what we need for the encoder. And this is going to be keys. Okay. I'm just going to name it so everyone knows what is here. It is on same level. It is. Okay. Now this encoder block is ready. We can copy it. And we would like to use 3 encoders, so I'm going to paste it 2 more times. Paste it maybe like this. Okay. And 1 more time. A little bit lower. Okay. Change the names. Encoder 2. This one will be 3. And don't forget to also then update the ports and nets. So this one is going to be column 1, encoder 2, this one encoder 2, and encoder 2. Okay, copy. We would like to connect it down here. And here. Of course, we also need the diode. And connect it to the rotary. Perfect. We need to connect it also to microcontroller. Again, copy the names. Of course, you can write it manually, but this is just habit. Okay, I learned the hard way. Copy and paste everything what was once created in Schematic. Just copy and paste it. I've seen so many silly mistakes in schematics just because someone made mistake when writing a net name. Do it also for this one. So this one is going to be column 2 and encoder 3. And change it here. Okay. Connect these to metrics. We need to add the diode. And encoders are almost connected. We just need to go on the microcontroller page and copy, paste, and connect it to the microcontroller. Okay. And the last one. Okay. Save everything. Perfect. If you need more encoders, again, you can connect them to some of these other pins. I tested up to 6 encoders and I had it connected this way. So I'm going to make notes where I connected encoders on my bigger keyboard, so you know it will definitely work. If you need more encoders, you can connect them this way, okay? So that would be encoder 4, this one would be encoder 5. And encoder 6. These are just nodes, okay? They are not real connections. Cool. What else is missing? Do you know? LEDs. So QMK, RGB, LED matrix. How we are going to connect our LEDs. There are more ways actually, and we would like to use this. This is a special LED, addressable LED. Basically, these are the pins which are on this LED, classic, just ground and power. But this is a special one. It has also power for the control logic. But there is this input and output pin, which can be used to tell the LED what kind of color it should be using. So I'm going to find something similar here, RGB LEDs in stock. And we need a special one. We need a special one because we would like to mount it upside down, not this one. Not this one. I'm looking for one which we can solder upside down. This one. This is a good one. Okay, have a look. This is exactly what we need because, you know, we don't want to place this LED directly under the button because there is no space. There is the button. So we need to place it on the bottom of our PCB and make a hole like this, see? Make a hole and then shine through the button. But the LED itself is placed on the bottom of the PCB and it's placed upside down. Okay, see? So it's very special LED. And we then just need to adjust a little bit the firmware to make it work. Because as I said, this is not exactly the one which was in the list, which we double checked, but it's fine. We would like to maybe make some adjustments. No, oh, it looks good actually. It looks good. They have a nice 3D model and it's placed upside down, so we can use this. Cool. I can close this. I was worried that we have to make some adjustments in this symbol or footprint on 3D model. I'm going to flip it because I would like to have input on the left side, output on the right side. And we can double check the datasheet. So right click, view datasheet, and let's have a look how we need to connect it and how it works. So it only has these 4 pins and VDD 5 volts. This is important, very important. We need to use 5 volts to power up this LED. 3.3 would not be enough. So I'm going to copy and paste this and I'm going to rename it plus 5 volt LEDs. And you probably know what we need to place here? Decoupling capacitor. Okay, I'm going to copy this and paste 100 nanofarad capacitor here. It helps to keep the quality of power rail when you use the coupling capacitors. And also, you know, it helps the chips to work reliably. Okay, save. Now, how they connect it? Oh, they connect it like this. It's very simple. So output goes to input of the second LED. Everything what we need to do is basically we need to copy this and just paste it here and connect the output from this first LED to the input of the second LED. Okay? I'm going to name this connection. I'm going to call it LED1 input, and don't forget to save, copy, and just paste it. So together we have how many LEDs? 9 LEDs. Paste, paste, few more, and done. Okay, so this one is going to be LED 2. So the first LED will be LED 0 because in the software they call it like LED 0, 1, 2, 3. That's why I started from 0. It's then easier in the software when you program or when you access these LEDs, you will know which one is which one. Okay, so this one is 7, and here this is 8. Save. We need to connect the first LED, and so on this page it is very simple. We know we need to go to the page with the microcontroller. So I'm going to use this input port, and I'm going to call it LED 0 input, and the last LED is not connected. Okay, but now what with this one? We can't directly connect it to microcontroller because we are working with the 5 volts here, and the input is expected 5 volts. If you use 3.3 volt, it may not always work properly. So we are going to find a buffer which will help us. Search for logic. Because, you know, because of the specification of the 0 and 1 level, or low and high level, is different for different voltages. That's why we would like to use a buffer. So I'm going to find one. Let's say this one. We can use this one maybe. They have different footprints, see? So I'm going to use this one. I'm going to copy this part number, and we are going to place it into our microcontroller schematic. It's a very simple component. It only has power, input and output. And basically we will connect the power to the 5 volts, so the output will have 5 volts, and input will be 3.3 volts, but this is a special chip which will work with both levels. This is not a ideal chip, so later we will change it again. This is the third part of schematic which will be changing a little bit later. I will then explain why. So connect the output to the LED 0 and connect the input to the microcontroller. Okay. Which pin we can use? Again, we need to check how this software works, but basically again we can use any pin, so that's good. I'm going to use this pin number 24 or GPIO 24, pin number 36, and we will use this 27 ohm resistor again to keep the quality of the signal good, because sometimes the buffer can be very far away from this microcontroller, especially if your keyboard is very large, and this 27 ohm resistor can help. Don't forget to name the names. So this one is going to be LED 0 underscore res, and this one is going to be LED 0 underscore buff, like buffer. Copy this net name and connect it down here. Now notice the pin number 1 is not connected on this specific buffer, but sometimes if you can't buy this component, maybe you can use different one. So sometimes it can be useful to connect the not connected pin together with the input pin, and don't forget to connect the ground pin. Okay, we use decoupling capacitor again close to this chip. You already know we need to place decoupling capacitors close to the chips, and I'm going to name it level translator. So this translates from 3.3 volt logic to 5 volt logic. Okay. We also need this power for LEDs, and I'm not going to connect it directly to +5 USB. I will use a very small resistor. Theoretically you can use 0 ohm resistor, but I will use I'm not going to use 0 ohm resistor because it may be useful for a little bit higher currents to use small resistor like 0.1 ohm resistor. Again, some people may be asking why. It can help to keep the quality of the power rails. So find one, for example this one. I use a little bit bigger one, okay, because there may be, depends how many LEDs you will have, but there can be higher current flowing through this resistor, so I use bigger footprint. Because in our case, in our keyboard, we are using 9 LEDs, but maybe when you are building bigger keyboard, you need more LEDs. My big keyboard is using 50 LEDs. And I also place 1 microfarad capacitor to filter the power, to help to filter the power. Okay. Save. Now we have this user LED which we can connect to these indicators. So search QMK LED indicators. These are like, you know, num lock, caps lock, scroll. You can connect these functions to this LED, but I would like to add one more LED, RGB LED, and then use these special features to show, for example, what kind of layer we are using on our keyboard. So I'm going to find this small 1mm by 1mm size LED. This is RGB LED, so red, green and blue in one very small footprint. And we are going to connect this to 3 pins from our microcontroller. And then later, when we will be doing software, we will use this LED to tell us, as I mentioned, the layer of the LED. I don't like this symbol. I'm going to change it. So in project libraries, we would like to save this device into our personal library. And if you don't know, by the way, if you don't know what are the layers, then basically layers, it means, for example, you can specify different layout on or different shortcuts for different software. So if you go to different software, suddenly all the keys can be configured differently. In one layer, one key can be Ctrl+C, and in another layer, it can be completely different shortcut. It's very useful. So I'm going to make this nicer. So pin number 1 is the common pin. I'm going to delete this, and I'm going to rotate this. I like to have schematic created the way it's very easy to understand. That's why I'm redrawing this symbol. Just, you know, have a look and you immediately understand how these RGB LEDs are connected. Okay, delete this and draw it like this. Okay, and the other side is connected together. So place line and connect everything together. Also, we would like to put a circle into middle and change the size, make it smaller. Okay, fill it up. So use the brown color. You can see the number of the color there. Okay. Also, I will place some notes so we know which LED is which one. Okay, we need to double check in datasheet. So open datasheet and okay, pin number 1 is plus, 2 is red, 3 is green, 4 is blue. 2 is red, 3 is green, and 4 is blue. Okay, see, this is much nicer. Much nicer than the original symbol. I'm going to delete this and place the new one. Perfect. make it nicer. Save. Close everything. We don't need this. And we can connect it. So we need resistor for every single LED. I'm going to place them down here. We can use 1K. Copy and paste. Paste. Okay. 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 Also the other side. And everything is connected to 3.3 volt. Now, this one I'm going to call user LED 2 are red. The next one is going to be, you can guess, green, and the last one is going to be blue. And we need to connect these to the microcontroller. And we have to use some of these pins, so I'm going to delete, or I'm going to move it, so you still remember which one you can use for the encoders. And I'm going to connect this RGB LED here instead. Okay. Now all the other pins, they are not connected, so we can mark them. And this one, actually I tested this one pin. I connected it to a motor, so you can have like haptic feedback. If you like, you can play with this. I'm going to name the RGB LED. And perfect. Save everything. So this is the haptic motor. If you like, you can test it. You will need additional circuit there, ideally with a transistor, but we also need these mounting holes. That's what we are missing. And also we would like to add this special holder for the metal plate. So we would like to add these few more components down here. And it means we need to learn how to create completely new component, because these are not really like standard things in the libraries. So first I'm going to create mounting hole, standard mounting hole, which will be used to screw the PCB to the enclosure. And it's a very simple component. It's just a one pin component. So place one pin. Be sure the grid is 0.1, and end of the pin is placed on 0, position. We don't want to add this mounting hole into bill of material because it's not real component, and designator is going to be MH, mounting hole. hide this pin name and add circle, maybe like this. Few adjustments, make it smaller, wider, fill it up. Okay, and this is symbol for mounting hole. We would like to create also footprint, so how the mounting hole is going to look in PCB. So create new footprint, name it like this. It's footprint for our mounting hole. Save. And what is going to be in the footprint? Do you know what is the mounting hole? It's just a path. So place a path and adjust the size of the path. So it's multi-layer number 1. That's very important. Okay, here you can see pin number 1 is used in the schematic symbol, so we need to use pin number 1 also in the footprint. And the size, be sure it is in millimeters. We are going to change this size to 7.5. Okay, and the hole is going to be 3.2. So it's for screws of the size 3 millimeter. And that's it. That's mounting hole. Okay, add this footprint to our symbol. So in personal libraries, this is the footprint what we have just created, and just confirm. There is no 3D model for mounting hole, so I'm going to save this, and I can close this, and this, and we are going to add the mounting hole into our schematic. So in personal libraries, refresh, this is the mounting hole, and place it. We create mounting holes in the schematic because, you know, mounting hole is connected to ground, and that's the reason why we would like to have it also in the schematic. Save everything. But I don't like this number 1. It looks ugly, so I'm going to edit this device again. Yes, I'm just going to move it like this. Okay, save it and close it, and it's automatically updated also in the schematic. See, so if you need to update a symbol which is already in the schematic, you can do it this way. I'm going to place 4 of them. We will have one mounting hole in each corner of our PCB. And as I said, we would like to also connect them, okay? Connect them to ground. So I'm going to do it. Okay, I'm going to copy this and paste it. Perfect. Now, description. So we know these are the mounting holes, and everyone else who is looking at your schematic knows these are mounting holes. Okay, and also here I forgot to add the description for the LEDs. So let's name these key LEDs. And there is one more component what we would like to create. It's the metal plate holder. So if you search for keyboard plate mounting, you will find out there are all the kind of styles what you can use in your keyboard. And there is not only PCB but also a plate which holds the switches in the position. And we need to find out what is the length, what kind of length for this standoff we need. So I'm double checking. So this is the thickness of the plate, and we know how far it goes from the PCB. This is the length of the standoff which we need on our PCB. It's 3.5 millimeter. I'm going to find this kind of component. They actually make them, and you can solder them directly on your PCB. Super useful. It is basically a standoff. You will see it. It is a standoff. We need 3.5, and we would like to use this one. This one is for soldering. So basically you solder this on your PCB, and then you can put the metal plate on the top of this and screws inside of this standoff. So I'm going to create the new component. I'm going to call it like this because that's the name from the manufacturer. Save. And again, it's a simple pin connected to ground. We will connect it to ground in the schematic, but that's the reason why we are putting a pin here. If there is no pin, we can connect it. And it's very simple. It's very similar to the mounting hole. Looks like this. Symbol looks like this. Name. I'm going to put here name. Standoff. M 2.5 and L is 3.5. Okay. And maybe I can copy this description here. So next time when I will go through my library, I will immediately know, oh, this is the standoff. It is in bill of material, and I'm going to change the designator to MH, like mounting hole. And I would like to add these some parameters like manufacturer part number, because this is super helpful when we generate the BOM, bill of material. Then all this information where we can buy this standoff will be included in the bill of material, so we don't have to search for it again. We only order them based on this information. Okay, copy and paste it, and also part number, copy and paste it. Okay, we also need footprint. Again, footprint is very simple. I'm going to call it standoff and the size. I like to put that the size because then you can have you know, different kind of standoff or different kind of mounting holes. And we are going to place a pin or path into our footprint, and basically we need to only double check the size. It will be inside of the data sheet. So it is in millimeters, and diameter is going to be so recommended length pattern, diameter is here, okay, and this is the hole. Okay, let's adjust the size. Perfect. non-plated. But I would like to keep it plated. Not plated, it means there is no copper inside of the hole, but I will keep plated, yes. I think it will be maybe a little bit stronger. I'm worried that if we only keep the copper at the top, that it may fall off from the PCB, maybe, I don't know. This is the stencil suggestion. So this is the way how it's going to be soldered. Stencil is basically going to specify the shape of the solder paste on the top of this on the top of this path, and we are going to draw it manually because it has quite a special shape. It looks like these 4 parts. I'm going to, so here are the dimensions. I'm going to adjust it. So here I'm going to use 1 millimeter and do it this way, okay? Okay, perfect. So this is 1/4 of the stencil. Copy it from the middle and then paste it into middle again. This is very important. Always when you do copy in this PCB or in the footprints, it will also ask you where you would like to pick it up. So this time use the 0, 0 position. Compare it. It looks perfect. It looks exactly like it is recommended. So we can save it. We can use it in our symbol. I'm going to select the footprint, what we have just created. Here it is. Confirm. Save. And now 3D model. There is this 3D model available directly here. I'm going to download it. This is the file what I just downloaded. I'm going to place it inside of our project, rename it, and we will add this 3D model. So when we have a look on the 3D model of our board, we will also see this standoff. Super useful. Upload 3D model. So we can use it in our library. Here it is. Open. Save. Now 3D model. Personal. And here it is. We just need to move it down. So I'm going to change this Z. Move it down. Oh, looks super cool. Confirm. Save. And we can close this. Go to libraries, personal, refresh, and place this standoff inside of our schematic. So this is super useful. Again, if you would like to create your own components, your own symbols, now you know exactly how to do that. Connect all of them. We need 4 of them and connect all of them to ground. Do it maybe like this, and here, and here. Perfect. I'm going to copy description, and I'm going to change it to metal plate holders. Make it nicer. Okay. This was the last component for our schematic. Well done! Don't forget to save everything. I'm going to move it a little bit down so it looks nicer. Okay, so this is finished. This is also finished. I'm going to name these nights. I forgot to name these nights. So I'm going to name them. They are very important. Okay. Perfect. And I would like to add here also this 2.2 microfarad capacitor, because the power supply will be a little bit further away from the microcontroller. So I would like to add this little bit bigger capacitor also close to the microcontroller. I move this 100 nanofarad here, make space for the 2 micro 2, so it looks nice, and put it here. Okay. Now, component designators. Here, notice C15. We are going to do annotation. We are going to remove all the component designators. Watch what's going to happen. Now it's C question mark. All the components, they have question mark now, okay? But this one I would like to call J101. This one I would like to call J102. So you can manually change the designators of the symbols in your schematic, but you can also do it automatically. I will change manually only a few of them. So this one is crystal, and for all the others, go to Design, Annotate Designator, and on current page, we would like to add page number and watch what's going to happen. Okay, so for all the others we can automatically name all the components. This one is still U101, that's how we name it, and this one is still J101, but all the others now they are automatically renamed. These designators are very important. Okay, save everything. We are going to do something similar on this second page. Here, I would like to call this differently. I don't like the U designator, so I'm going to select all of them, and I'm going to change this to J question mark, because they are really like connectors, okay? And these encoders, they call them switch, but I'm going to call it encoder. So this one is going to be encoder 201 because it's on schematic page 2. That's why it starts with 2. 202 and 203. So name them manually. And what else? These LEDs, maybe I would like to call it differently. So I'm going to select again all the LEDs, and I'm going to change it to LED question mark, and I'm going to manually name all these. So this one is 201, 202. I'm naming these manually because if I do it automatically, they would be mixed with the this metal plate hole that would be mixed with the mounting holes. I would like to have nice names. Now name everything else automatically. So current page and add page number, and watch what's going to happen. Perfect. Okay, have a look. 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 5, 6, 7, 8, 9. Okay. And these LEDs 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And mounting holes. Okay, perfect. Cool. Save. Now design and check DRC. Clear, check. There are only some warnings. These warnings are not really important. Ignore them. If there are any other errors, try to fix them, okay? Now design and update schematic to PCB. This is the moment of the truth. We are going to import our schematic into PCB. So we are going to add all the components from our schematic into our PCB. This is one of the coolest moments when you are designing boards. So let's have a look what we have created. Apply. And these are all the components from our schematic. Save everything and let's have a look on 3D model. This is so cool. This is why we add 3D models to our symbols. See? Here are the switches and the sockets, LEDs, standoff, encoders. Okay. You can see the microcontroller, regulator, flash. Wow! Close this. We can close all these other tabs, which we don't need. And we are going to work on PCB. Fantastic job! You finished schematic, and now we are going to place all the components on our PCB. So let's continue. The link to the next part is in the description. And don't forget, if you would like to learn more about electronics, check out our online courses about schematic design, PCB layout, EMC, measurement. We have courses about KeyCap, Altium Designer, and more. Go to fedevel.com and have a look. Thank you very much and see you in the next video. Bye!